Okay, this video is going to cover Chapter 4 of the curriculum, and as we can see here, Chapter 4 is entitled Ether Channel and HSRP, which stands for Hot Standby Router Protocol. So these are the two main topics that we're going to be talking about in Chapter 4. If we go to the introduction, you can read that on your own, but there's just a couple of things that I want to point out that we'll be covering. The first is Ether Channel, which has the very first words here say link aggregation. So Ether Channel is one type of link aggregation where we take multiple links and put them together to get more bandwidth. Link aggregation implies load sharing over multiple physical paths between two devices, as opposed to having, with spanning tree protocol, it blocking one or more paths. HSRP, as I said, is Hot Standby Router Protocol, and what this does is this allows multiple routers to appear as a single router. It's a method of fault tolerance. And it also allows, the important thing it allows is those routers, if they are the default gateway, it allows more than one router to route for the default gateway. That's called first hop redundancy protocol. So if we move on, 4012, I do want to assign this. It'll be appearing in Blackboard. It says that you're supposed to share your presentation with the class. We're not going to do that. Obviously, we don't have class. Even if we did have an in-person class, I probably wouldn't do this. But what I would like you to do is make the presentation that they talk about, and then either, depending on your software, export it to PDF or print it to PDF, and then upload it to Blackboard. Okay. 41111 is Introduction to Link Aggregation. In this case, if we have redundant links, like for example we have two from this router to this multi-layer switch, one of those would be blocked by spanning tree protocol so that we did not have loops. But using link aggregation, we can balance traffic over redundant links to increase the bandwidth. And here on the next one, they will show you this little oval or circle, whatever you want to call it, that does two or more links inside of it. In this case, they would be using Ether Channel. So we have two physical connections. We have two physical connections here, but they will appear as one, just at a higher bandwidth. Okay. There are some implementation restrictions. Actually, let me back up. I forgot something. So there are a number of advantages. I just discussed the graphic, but there's some important stuff over in the text. When you have things in Ether Channel and you need to change some characteristic of that link, usually you can do it on the Ether Channel and it will do all the underlying links for you. This allows us to increase the bandwidth, as I mentioned before, without having to buy additional, possibly more expensive equipment to meet your needs. As I said, it was load balanced, so if you have 5 connections in your Ether channel, it will balance the load over all 5 of those. Aggregation of the connections makes it become one logical link. So like I said, we treat it as one link, even though it may be multiple physical links. And there is redundancy built in this. If one of the physical links goes down, the Ether channel will stay up and just load balance between the remaining physical circuits. Okay, there's some things that you have to worry about. They're kind of point out here that we have, looks like 6 ports formed into an Ether channel on the left, and then the 4 ports on the right are another Ether channel. We call these a channel group. There are some restrictions. We cannot mix interface type or speeds. So in this case, these are copper connections, so everything in the channel needs to be copper. If they're 100 megabits, they all need to be 100 megabits. If they're all gig, they need to be all gig. And just kind of a fact, Ether channel does run in full duplex, so we can have communications both ways. And in the case of using a 100 megabit per second switch or connections, we can group that together to go up to 800 megabits per second. If we're using gig connections, we can group them together to get a maximum bandwidth of 8 gigabits per second. So we can have a pretty good increase if we have enough ports to put in our channel group. Here they're showing you a protocol that is used. It's called Port Aggregation Protocol. It is abbreviated PAGP. You can have this on, which means there's no negotiation. You can have it set to desirable, which means I would like to do Ether channel, but it depends upon what the other end is able to do. Or we can set it to auto, which means whatever the other side does, we're going to do as well. So down here at the bottom, we have some of the PageG modes showing S1 and S2, and it will show you if they're both on, it will establish a channel. If one's desirable and the other is set to auto or desirable, it will create a channel. And all other possible combinations will not allow an Ether channel to be created or for the protocol to come up. Another protocol we have is LACP, which is Link Aggregation Control Protocol. It's just another method of dealing with channel aggregation or link aggregation. And for it, we have the same type of table down here. On and on, active, active, passive, active, we will get a channel established. All the other possible combinations would not establish a channel for us. 4124 is an activity. It's actually 3 different activities if you look down here at the bottom left. But you can go through and make sure you understand the different modes and some of the terminology. So you can do that on your own. Okay, 4212 is titled Configuring Interfaces. These are the commands to configure Ether channel using LACP. So this is showing you a configuration that will work. Some of the things that go along with this slide is first, all channels, all interfaces must support Ether channel. All ports need to be the same speed in duplex. All ports must be on the same VLAN, that's one we haven't mentioned before, and all ports must allow the same range of VLANs. So here we have same speed, same duplex, same VLAN, so we would get an Ether channel being formed. In the second slide, the speed matches, the VLAN matches, but the duplex does not match. So since all those things don't match, no link would be formed. Now then, where I thought we were going, configuring interfaces. So this is using LACP protocol. We talked about a range of ports. So notice here we have an interface. We're going to give a range. They're FA0/1 to FA0/2. So in this case we have 2 channels as shown in the graphic. We need to assign them to a channel group. We need to go in and set the interface to be on port channel 1, switch port mode trunk, so we're going to allow multiple VLANs, that's what trunk does, and then we're going to have trunk allowed. I'm not sure we've seen this command before, but over this Ether channel we're going to allow communications for VLAN 1, which is the default, VLAN 2, and VLAN 20. The second figure is basically, can you recall and enter those commands correctly, so you can type it in like you were interacting with a switch and check it. You can have it show you step by step with show me, or show all will basically just show you all the things that were in the previous graphic. For 123 is a packet tracer assignment. I will assign that, so watch for that appear in Blackboard. It's a relatively short lab, just a tad over 2 pages, but it has you go through the steps of configuring Ether channel on the topology that's shown. Okay, as I mentioned last chapter, sometimes Cisco is real good about having a packet tracer version and then a lab version. You can choose which one you want. Sometimes they just have labs, sometimes they just have packet tracers, so they're not super consistent across all the Cisco 1, 2, 3, and 4 curriculums. But here, this is a lab. It's entitled Configuring Ether Channel, so it's the exact same thing that you will be doing in the packet tracer. Although this is intended to be done in the classroom on physical equipment. So we will probably not do this at all since you're doing it with packet tracer, and I don't see any great advantage for you just replicating your work on the NetLab. Okay, 4221 is called Verifying Ether Channel. So this would be what you would do if you wanted to see if Ether channel was set up and find some of the characteristics. So here in the first graphic, they said show interface port channel 1, and it says port channel 1 is up and functioning. The line protocol is up, which means we're connected, and then it gives you some other information about the Ether channel. Here in graphic 2, show Ether channel summary. So it's saying we have one group, port channel 1, we're using LACP, and we have the following ports or interfaces in the Ether channel group. So FA0/1, FA0/2, which is what we would expect. The P here means it's bundled into a port channel, so it tells us that it is being used for Ether channel. Graphic 3 is show Ether channel port channel. So it's going to show we have group 1. It is PO1 is the name of the channel. This is how long it's been up, 6 hours and 23 minutes. We have 2 interfaces in this group. We're using LACP. So that gives us some information about the Ether channel from a little different perspective. Here we're saying show FA0/1 Ether channel. The port is up and it is showing an LACP priority, giving the state, and then down here it's giving us more information such as the device ID, the age, etc. And finally, the last one is a practice on your own the commands we just talked about. So you can do that on your own to practice and make sure you understand this. 4222 is called Troubleshooting Ethernet. What happens is they're showing us here a situation. It's showing us that the D flag means down, and if we look in our port channel 1, for some reason port 1 and port 2 on FA0 are down. In this mode, top half is switch 1, bottom half is switch 2. Notice that on switch 1, the channel group 1, the mode is on. If we go down here, it is S2 is channel mode desirable. It will not, based on the table that we saw back in 4.1.2.2, will not establish a connection. In 3, we go through and we set the mode on S1 to be desirable, And in that case, the ether channel does come up as shown down here in the status. Okay, Packet Tracer 4223, troubleshooting Ethernet. I will assign that, so watch for it to appear in Blackboard. Super short, less than a page and a half, so that shouldn't be too bad. Just like we had before, 4224 is a lab with the same name, so we will probably never do this because I assigned the Packet Tracer version of it. Okay, starting into 4.3, I don't know that they say it very clearly or say it for a while, but we're talking about what's called first hop redundancy. And this is entitled Default Gateway Limitations. So in the past, when you've configured a default gateway, it is the router that sits on the edge of our subnet that if our devices do not know how to route packets to their destination, we send it to the default gateway, and then the default gateway, using its router table, would send the packet on to its next hop. Now what they're showing here in the graphic is our default gateway for some reason is down. That means any packets coming from PC1 or any other devices that might be connected to this switch are not able to communicate off the local network because that is down. So basically what they're saying is having one default gateway, if that gateway goes down, you're going to have issues. So the way we solve this is we create redundancy to prevent this type of failure, and we do that by creating a virtual router. And how we do that is we take two or more routers, but we make them appear as one virtual router sharing the default gateway information. So the IP address and whatever MAC address is associated with the default gateway, these routers are able to share that information and take over if for some reason one of the routers fails. And again, that's known as first hop redundancy. So it's the first hop a device on the network would be taking. So the steps for failover is when the current router fails, which they're showing here, the standby router becomes the new forwarding router. And what happens is they do a better job of showing this in the future, but this virtual router is usually kind of half grayed out like a ghost because it's virtual. So this virtual router will then send it over to the new forwarding router, and our traffic continues to flow with zero disruption of service. Okay, this activity, actually two activities, identify first hop router redundancy protocol terminology, allows you to go through, drag and drop, and then check your answers. So after you study that and think you're ready, you can go through this activity and make sure you understand it correctly. 4315, first hop redundancy protocols. So here in the graphic is what I'm talking about. They're doing a little better job. We take two routers up here. We create a virtual router. Our traffic goes to the virtual router, and it will pass it through the active router on its way to its destination. If the active router fails, then the virtual router goes to the standby, and it starts forwarding packets. Again, some things down here. The second bullet point, very, very important. The virtual router has a virtual IP, sometimes called a VIP, and a MAC address that are shared between the two routers. If you want to see if it's up or not, you can say use the show standby command. That'll tell you whether it's active or standby. And then down here, HSRP is a Cisco proprietary protocol, so this is only going to work on Cisco equipment. Here's an activity to verify based on a definition or a statement which of these protocols does it belong to. Okay. Back here on 4315, I failed to point out that there's a lot of information over in the text. Hot standby router protocol we've talked about. It works for IP version 4. It works for IP version 6. And there's gateway load balancing that allows you to load balance between a group of redundant routers. So one router just doesn't get hammered with all the traffic. We also have GLBP, which is for IP version 6, and it provides auto router backup for IP version 6 host. And then ICMP router discovery protocol. This is a legacy protocol that allows IP version 4 host to locate routers that provide IP version 4 connectivity to other non-local IP networks. Okay, so now 4316 activity you can do on your own. 4231 is talking about hot spare router protocol overview. We've already talked about some of this. It allows gateway redundancy. So here they're showing, you know, like I said, this kind of ghosted out. So here's the IP for the virtual router, and here's the MAC address for the virtual router. Okay, there are different versions of hot spare router protocol. There's version 1, which used multicast. There's version 2, which will allow more supported groups. Version 1 only did 255, actually 256, 0 to 255. And then group 2, they expanded up to 0 to 4095. Version 2 also added support for authentication. So you have something called an MD5 checksum that verifies that most of the time when you're doing it on a host that the contents of a file are valid. In this case, we would be verifying that the traffic or packets is valid. Okay, priority and preemption. So we can have priorities established, and the router that has the highest priority will become the active router, but you can request to be preempted. So if somebody wants to take over being the primary router, the other router can try to preempt it and say, I want to become the active router. The one kind of real life situation I can think of is you need to do, you did maintenance on the standby router. You now want to take over from router 1, make sure that connection works fine, and when it does, do the upgrade or whatever changes you made on router 1. So it kind of helps with maintenance. Here are some of the things, different states that a hot spare router protocol device can be in. When it's in the initial state, this is entered by configuration change or when the interface first comes up or comes available. If we're learning, the router has not determined the virtual IP and virtual MAC address yet, so it has not seen a hello message from another router. Listening means that the virtual router knows, or I'm sorry, the router knows its virtual IP, but it is not currently the active router or the standby router. It's going to listen for hello messages from the active and standby router and figure out what to do. In speak mode, the router is sending out hello messages, which basically tell information about the device and can be used for the election process of figuring out who's an active and who's a standby router. Standby is the router that is a candidate to become the active router if the current primary router, active router, fails. And then the active router is the router that is actually answering requests on the virtual IP and virtual MAC address and sends periodic hello messages telling the other devices that it's still there and what's going on. Okay, 4325 is an activity on HSRP terminology and states. It's actually two activities. As we can see, there's two figures. After studying the stuff in 432, you can go through and do these on your own outside of class. Now we're talking about some new iOS commands that we may need to know. Standby version 2 says that we want to use version 2 of the hot spare router protocol. Version 1 is the default, so we want to change that. The virtual IP, you go in and you give the IP address. You say standby, what group number it is, and the IP address you want to use. You give the priority. The priority is between 0 and 255. The default is 100. You can change that priority to either more likely become the active router or more likely become the standby router. And then here is the command you would use to try to take over and preempt the current active router. Okay. Here's a sample configuration. Looks very similar to before. We have two routers connected to the switch. However, we have one virtual router, and what happens is when we send to the virtual router, it will send through whichever of these two is the active router. And then here is an example where on router 1 we're going into the G0/1 gig interface. We're setting the IP address, we're setting the version of HSRP, we're setting the IP address of this interface, we're setting the priority. No shutdown, of course, means we're bringing it up. It comes up. And then we go on router 2 and do the same thing to configure the other end of that connection. Okay, verification of HSRP. So we have a topology. I don't know if it's exactly the same as far as IP addresses and etc., but very similar to the two previous topologies we've seen. Here's the default IP address for the gateway and its MAC address. So now if we go to figure 2, we are on router 1. We say show standby. We are active. Here's the virtual IP and MAC address. We have allowed preemption, and the standby router is 10.3. So if we go back, this is router 1 over here, I think, and then it's saying router 2 is the default gateway. They didn't label the routers in the topology. Going to 3, we're on router 2. We do the same thing, show standby. We're standby. Here's our IP and MAC that are virtual. Preemption is disabled, and the standby router is the local device. If we go to 4, we're back on router 1, show standby brief. The main thing we're checking for is that the interface is active. Here we're on router 2. We are in standby. So router 1 is the active router, and it is in this router 2 is in standby mode. And then finally, the 6th figure is one of these do on your own to practice what we've been talking about. 4334 is a lab on configuring HSRP. I'm not really sure whether we're going to do this or not, but if we do it, it will be done on the NetLab. Okay, now we're going to study HSRP failures. So there are several things that we can fail on, and it's over here. We never elect an active router that controls the virtual IP. Nothing would get routed. If the standby router doesn't keep track of the active router can go down and the standby would never come up, or possibly the standby would come up inactive and we'd have both routers in active mode, which should not happen. Closely related, not figuring out when to pass one off to the other. I think we already kind of talked about that. And when we go through, if they never configure the virtual IP and virtual MAC addresses, then of course this is not going to work very well. Okay, what are some commands we can use to debug? So figure 1, there's 6 figures here. Figure 1 says debug standby question mark. So we're using the context sensitive help system, and it says, well, the possible things you could use here is errors, events, packets. So that would show you some of the things that are going on. So you could turn on these debug modes. So here we have a topology. Again, I think it's the exact one we've seen in the last 3 figures now. We can log into router 2 and say debug standby packets, and what this is going to do is it's going to show us packets that are coming to and going from router 2, and in this case we see hello messages that are coming, in this case really close to each other. So it sent this message and then this message. In graphic 4, we're going to have router 1 failing and router 2 being elected the active router. So we can see here that we stop seeing packets, and then it'll go through and get some information, print out some debug messages, and finally say, hey, I went from the standby router to being the active router because for some reason router 1 disappeared or configured or was not configured properly or changed configurations. In this figure, router 2 is powered back on. I'm sorry, router 1's plugged back in, so it'll go through, it'll exchange information, it goes into listening, and then it will go ultimately into standby mode. Now here we log into router 1 and we administratively shut it down. So it was the active router, it goes to the initial state. It resigns being the active router, and then router 2 will take over for it. So kind of the important messages are highlighted here in this kind of red color. This is an activity that you can do on your own to look at some HSRP configuration issues. (4344) is a packet tracer activity entitled Troubleshooting HSRP. I will assign this one. It's short like most of them have been. It's only 2 pages long. They'll be due in about a week or 2, but watch for the announcement in Blackboard. Now if we go to 4411, this is a class activity. Sometimes I have you do the class activities, like I think I had you do the activity at the beginning of this chapter. I don't see a lot of benefit of actually going through and doing this formally, but you should still click on the activity and possibly the system requirements to implement Ether channel and read those documents. Okay, you should have had these in Cisco 1 and Cisco 2, but usually, after 2 or 3 chapters, they'll have something called a skills integration. So basically what the skills integration is taking, information that you've learned kind of very focused on particular protocols or different parts of a concept, and can you put these together? So this would fall under the category of critical thinking. Again, when you see skills integration, you should think multiple concepts, and you should think this is going to take me a little longer to complete than a normal packet tracer. It's only 4 pages long, but most of it's just kind of giving you background and steps that you need to do to configure VLANs, configure VTP, configure routing, configure Ether channel. So, like I said, that's the multiple concepts. I'm pretty confident I will assign this, and I'll give you plenty of time to complete it. So watch for that in Blackboard. And that takes us to the chapter summary, which means we've finished chapter 4. Relatively short chapter. At some point, I will post an announcement to Blackboard for you to complete the chapter 4 exam on netacad.com. But that finishes up this chapter.